Hello, my name is Han True. I am a first year biochemistry major, and this is my video submission for ACSSA Symposium. My research topic is called the cat compound, and I would first like you guys to meet my cat Ollie. He is about a year old, and he absolutely loves catnip, and that was what really motivated me to look into my research or start focusing on catnip. I wanted to find out on the chemical level what caused cats to respond the way they did to catnip. And so their initial response would tend to be entering a euphoric state, and then afterwards they would enter a very relaxed state. I would be focusing on the euphoric state or exactly what caused them to react the way they did. Example is this my cat Dolly. He had recently just had catnip, and this was his response, very focused and hyperactive and purring, very adorable. And then the result was this. Very chilled, very relaxed. Disclaimer, no felines were harmed in this process. He was very happy to get some. So a little bit about catnip, not focusing on the chemical level just yet, is that the plant or the scent that was given off by catnip was a defense mechanism to repel or deter insects. So it's actually used in insect repellent commonly, and nowadays we often use it in catnip. So something that I think was very interesting is that not all cats respond to catnip the way we often see them do. It's the reaction they have is hereditary. Um, so only a certain percentage of cats respond to it in a crazy way. Also, young kittens don't respond to catnip at all because catnip, or at least the scent of it, mimics cat or sexual pheromones. And so because young kittens have not yet reached sexual maturity, they cannot respond to catnip just yet. So moving on to the actual cat compound is called Neptulactone. So Neptulactone, otherwise known as Neptulactaria, here's the formula here, is a volatile organic compound. It's in a class of compounds called iridoid, which essentially means they're found in plants, commonly found in plants. So something that I thought was pretty interesting was that they undergo a two-step pathway. So it doesn't go from one compound immediately to Neptulactone. You have to undergo two steps. So of course there's more steps prior to this, but the main cycle is called starts off with its precursor oxygenol right here. And so what happens is, so oxygenol is a monoterpene. It's reduced by the enzyme iridoid synthase, and then an intermediate is the result. You don't immediately go to Neptulactone, you go to the intermediate. And so the research found in my research is that actually there were three enzymes that cyclized the intermediate, and that was NEPS1, NEPS2, and NEPS3. For some reason, at least what I found in my research is that only NEPS2 and 3 were the only enzymes that, when cyclizing the intermediate, resulted in Neptulactone. NEPS1 did not yield Neptulactone. I thought that was interesting because they found three enzymes, but only two of them worked. But I thought that was very interesting. So I hope you guys enjoyed this, learning about effects on cats. And thank you so much for watching. Okay, bye-bye.